Jamie, thank you very much for presenting today. Senior Solutions Engineer at F5 for Shape. The stage is yours.
Okay, thanks. Apologies for the short delay and the technical glitches, but we're there now. So I think today my role is to give you an introduction to the Shape anti-automation technology, or bot detection and mitigation, if you prefer that term. There's myself. I'm, as Hans said, I'm a Senior Solutions Engineer for obviously F5 now, but previously Shape. So came across with the acquisition and been working for Shape for 3 years. And I'm accompanied by Slobodan, who's one of our account managers or account directors for the Benelux region. Okay, move on, please. Okay, we'll take an overview of the kind of landscape and kind of what we do to start with, and then we'll look in a bit more detail at the technology itself. I'll try and keep it fairly pacey since we've lost 10 minutes already. So as mentioned earlier, Shape's core technology and where we started was to solve the so-called bot problem or automation problem. I typically use automation as my term rather than bot. I think that conveys, you know, a bit more seriousness or weight to the actual problem that we're discussing, rather than calling them bots, which are kind of the symptom of a particular problem. But anyway, our core technology is a platform that's there to defeat bad actors from exploiting your applications, your web applications and mobile applications for their own benefit, i.e. to hijack accounts or get into your application and exfiltrate data, whatever the motivations are. So they're exploiting the functionality of the apps that you put out there for your good users. So the idea is that Shape is able to determine whether it's legitimate traffic, good users, or unwanted automation that's exploiting your applications. Now we have different additional products that look at manual fraud and making logins frictionless, but today we're focusing on the automation part. So next slide, please. Okay, so I guess we know this. Most of the time, why attackers do this, and remember, it's people behind this activity. The bots are the symptom, not the cause. Okay, so we're dealing with the cause, but really it's the guys behind the scenes that you want to get to. But obviously, the prime motivator in any of things is usually some kind of value, and obviously value often translates to cash. So it may be that they're selling accounts online, for instance, and that's the way they see their value. But of course, there are other motivations. If we go to the next slide, one of those is exploiting automation at scale to influence people. So Facebook bots, pumping out political posts, and that might be the problem you're looking to solve. Alternatively, next slide, Slobodan. You've got things like TikTok bots out there. Obviously, it's not directly making money, but what they want to do is influencers become well known on the TikTok platform, which then may translate into money if they're being paid for stuff. But you can automate almost anything, and you can also get pretty sophisticated, as we'll come to look at. So next slide. Now, so automation is a constituent part of a bigger problem, which is usually labeled as fraud. So automation is leveraged to lower the cost to, if you've got a billion, let's say you've got a billion credentials available to you, there's no way you can test those manually, so you have to leverage automation. And automation is a cheaper option than employing 10,000 people to try and test these kind of credentials. So if you hit the next key, and you've got data breaches which feed, you just do the next one as well, Slobodan. You've got data breaches, and this is credential stuffing, which is a particular form of automation, of course. And there are others, you know, exploiting the areas of applications. But if we think of just the credential stuffing part of it at the moment, you know, data breaches which are freely available and are available, becoming more available all the time. You know, data breaches don't stop. So this is a constant feed of data, feed into an attacker's automation framework. They plug in those credentials, they test them against various websites, and they take whatever accounts they can validate from that particular exercise. And, you know, there's kind of two elements to this problem. You've got the upstream side of things. So if they get accounts from your site, that causes you problems and your users problems, maybe account lockout, maybe financial losses, maybe call center usage goes up, maybe there are chargebacks, etc., etc., etc. But there's also downstream fraud. You know, just because automation hits your site, the output of that automation may not be used on your site. It may be used downstream elsewhere on other sites. So any PII data, for instance, that gets exfiltrated from your site may well be used in a downstream kind of fraud scheme on someone else's application. So PII data may be used to facilitate applications for credit card, you know, credit cards or bank accounts or whatever it might be, or even just, you know, put for sale up on the dark web for other people to execute fraudulent fraud schemes. Next slide, Slobodan. So as mentioned earlier, what's going on here is users are logging into your application. Amazon's not a customer, so I just use it as an example. And they're abusing the functionality you put out there for your site. So they're using your apps as intended. They're not trying to get around them, they're trying to go through them. So, you know, a WAF is typically used to detect malformed requests, you know, SQL injection, cross-site scripting. These guys are, you know, it looks like legitimate traffic. So that's why we call it abuse rather than, you know, a vulnerability. Next slide. So the challenge is, this is what the traffic looks like that's using your application. How do we tell, you know, which of these cars is good and which is bad? You know, do bad guys always travel in black cars? No, they don't. You know, and is there any other indication from the outside whether it's a bad guy or a good guy trying to get into your application? Next slide. Now, following on from that, what we need to do is we need to identify these guys. And obviously what happens is, as they, you know, as your defenses get more sophisticated, so do the attackers. So there's this kind of evolution. There's an arms race that goes on in this this area where the attackers are not subject to change management control. You know, these criminal organizations or even nation states which do this kind of thing are not subject to, you know, weekly release schedules, change management, steering committees, all that kind of stuff. They can adapt and evolve very quickly. But typically they take this path. And this is typical of any organization, whether that be a household, you know, an individual or a company, is they start at the, you know, bottom left. They make it cheap and cheerful. They use standard tools which to just simulate network risks as cheap as possible. But obviously, as the defenders introduce, you know, tools to defend, so a WAF, for instance, and they do IP blocking, the attackers learn from this, and they just spread their attack across, you know, multiple IP addresses, hundreds of or even thousands of them. And then as they become more sophisticated, they practically control browsers. So they use real browsers to execute JavaScript, you know, headless Chrome and so on. And then if they need to become more sophisticated in order to try and defeat browser or behavior measures, then they start to imitate users. They use fake mouse tracks. They use capture bypass. So their scripts become ever more, you know, ever more complicated. And then there are custom attack platforms. So attackers take, you know, plugins, they adapt those plugins, they even build custom attack platforms, particularly in the mobile space. And we've seen all of these things, and Shape plays in this entire spread, if you like. We can defeat low-level stuff and we can defeat this sophisticated stuff. And that's down to the adaptability of our platform, which I'll come to shortly in how it works. Okay, next one, Slobodan. Okay, so it's important to understand that this, like I've said, this is dynamic. The bad actors that perpetrate these attacks are not operating on their own. They're not in a silo. There's a whole ecosystem out there of tools and techniques that they can leverage to perpetrate their activity. So for instance, there's tools out there that you can buy or rent. There are capture bypass services, which are pretty cheap to operate. There's even APIs that allow you to use multiple capture bypass facilities. Google nicely provided Puppeteer, for which there are plugins purposely built to try and evade fingerprinting technology, for instance. So there's a plugin called Stealth, which you can then customize to try and get round any defenses. Next, Slobodan. Rentable tools like Sniper, and there's also marketplaces out there for details that have been exfiltrated by malware. So Genesis is one of those. So if you look at it from a kind of cost basis, in order to get started with this kind of activity, it's not that cost prohibitive. Stolen credentials can be downloaded from the dark web, and obviously can also be purchased. There are proxies, botnets, and so on you can use out there, and you can use spread your attacks across many IPs. You've got tooling, which you can, in the case of Sentry MBA, which is the example there, you can download configs that are pre-built for particular sites, and obviously capture solving tools. Prices vary, but they're very low. Death by capture is $139 per 1,000 requests, and even cheaper if you sign up as a gold member. So it's pretty cheap to get started with this. So in terms of as an application defender, if you like, the sorts of things to look for are application indicators. Once you have a WAF and so on, and you're blocking IPs and attackers are going round you, they take their feedback and they adapt their attack. So they try to slide into your application in amongst all the legitimate traffic. But so it's important to look at application indicators to see whether there are anomalies that indicate this kind of activity. So a simple one here is, obviously what you want to be doing is measuring login failure rates and login success rates. And you can see there's a spike in the middle there of login failure, which indicates something strange is going on. And often these things indicate that there's kind of credential stuffing happening. But you can measure all sorts of things with your application. Obviously, credit card validation attempts, forgot password requests. All those kinds of things can be used as metrics and indicators of nefarious activity. Next. So here's an example of a traffic pattern. It doesn't really, this traffic pattern might be, okay, yeah, it might be legit, who knows? It looks a bit strange if you think of, human activity. But over a week, this was a US mobile operator. They thought they had a problem, but they weren't sure what it was. If you go to the next slide. So when we got in line on this, we were able to discriminate this traffic, because what we're doing is we're making judgments or segmenting the traffic based on our signals. So you can see at the bottom there, the green is actually legitimate traffic, and you can see there's a diurnal pattern. It kind of goes up in the day, down at night, up in the day, down at night, obviously, as people sleep or are awake. The rest of the traffic is automation. The red is attack traffic, credential stuffing, and so on. The orange is wanted automation, like testing traffic, performance monitoring, etc., etc. So you can see that a lot of their activity was unwanted. So when Shape goes in line and starts to act on this traffic, mitigate it, this is typical of the kind of process that happens. We go in line, and we monitor the traffic for a while. That's where you can see the left of the graph is green and yellow, which is green is good and yellow is flag traffic. As soon as we enable mitigation, the flag most of the flag traffic, because we don't want to block all automation if it's performance testing, for instance, or monitoring, the unwanted traffic is mitigated and turns red. That means we're blocking it. Now, the action we're taking depends on what the customer requirement is. It goes red, and as you can see, it doesn't stop immediately, and that's because it's automated. The attackers don't monitor it 24/7. You know, they set it going and they come back at certain points to check how it's doing or to get the results out and do something with those results. So you can see it continues for a while, and then it stops, and then they have a think about it, and then they turn it back on again and see what the problem is. And then they realize it's not working, they turn it off again, and then they start to reconnaissance and retool and try different things. They probe, they redevelop their attack framework, and they try again, and they're trying, you know, ways to get around it. This is what motivated attackers do. They don't just go, oh, it's not working, I think I'll leave. They see value there, so they come back and try other things. You know, and similarly, what they'll also do is they'll hunt around for different endpoints to attack. So they might transition from web to mobile if they can't find a way through the web. So we often see that as well, that you know, they'll hunt around for another way in via another application or a different platform. Okay, next. So what we're aiming for is to frustrate attackers. Now, this was a comment made on the Discord channel where I've blanked out the customer name, but the customer name is up there behind the orange box. And the guys are trying to attack our customer, and they're saying, oh, we can't get around, Shape Security are in there. Obviously, these guys are experienced because you know, they kind of know what to look for. So they're suggesting we're in and they can't get around it and it's a problem and so on and so forth. So this is the kind of stuff, and we see quite a lot of this in Discord, actually, for various you know, problems that the attackers are having trying to get around us. This is what we want. This is what we want to cause. And the reason we want to cause this is because in protecting the customer, we're causing the attackers pain. Pain means they have to work harder. Working harder means they have to spend more money and are frustrated, and it takes them longer to get what they want. And in the end, it's economics which dictate their activity. If it becomes too difficult, too much, they cost them too much money to develop their frameworks, they will go and move to another target. And this is the purpose, you know, of the technology. This is what we want to achieve. Okay, next one. Okay, so how does Shape work then? Let's have a look at how, you know, an overview of how it gets deployed. So typically Shape is not used to protect a whole site. It's used to protect what we call certain flows, protected flows or user functionality. So typically we would be on certain areas of the site like login, forgot password, create account, maybe checkout, maybe add to cart, maybe credit card validation, for airlines, flight search, those kind of key areas where the user is interacting for the site, inputting their data and receiving useful data back out of the application. We wouldn't typically be placed in front of, you know, a website homepage, for instance. You know, there's just very little point in being on protecting a homepage. You want to protect areas of the site which are important to the users and you as a, you know, data controller, if you like. So on an entry point, our JavaScript gets deployed. Okay, so that would be, in this example, it's the login page. That is used then to collect signals about the client environment and other things, which we'll come to shortly. And then there's a protected endpoint. So the flow is an entry point and an endpoint. And the endpoint in this case is the login authentication post. That post will have signals attached and it will be routed to a Shape cluster for inspection in real time. That means we can detect automation and also mitigate it in real time. So there's this flow where we're you know, deployed. Next.
And got stuck for a moment. Let me try to switch it manually.
Okay, so as an overview, we're in line. So on the web or mobile application, because we have an SDK as well, the principle is the same. We're deployed. We collect signals. Those signals then are attached to the outgoing request. The request hits your load balancer or some edge location, CDN. Load balancer could be big IP or whatever it is you use. That request is then routed to a shape cluster, which can be located either on premise or elsewhere, in the cloud, for instance, and it's inspected real time. If it's automation, it follows the red path, gets blocked at stage 1 in real time. And if it's human, it follows the green path, inspected by shape, sent back to the load balancer to the origin. The user logs in, carries on their business, none the wiser. So we're deployed. We're not asking them to fill any capture form in or anything like that. We're detecting everything transparently. Now that's stage 1. We also have stage 2. So Shape Enterprise Defense, our flagship product, includes support, 24/7 support from machine learning models that run on the traffic, humans, data scientists, and threat intelligence analysts, which monitor traffic. And there's a feedback loop. If we see requirements where we need to deploy custom countermeasures or where we need to deploy custom signals, for instance, for detection purposes, we can do that within Shape Enterprise Defense. And also we can apply flexible mitigation activity, whether that be to drop the traffic, return a particular status code, or return a particular response. Excuse me. Then we can do that. Next. So in terms of shape signals, we collect telemetry data that fall into 3 main buckets. We've got information about the environment, the browser, and so on. Information about the network, because we see the request routed through the shape cluster, and information about the behavior. So we can use all of those many signals around all of these things to detect and mitigate automation or detect the automation in the first place. So in terms of how we collect the data, we deploy our JavaScript, and within that JavaScript, it's configurable. So, excuse me, we have modules within the JavaScript that can turn which signals we need to deploy for any particular customer, particularly on SED. So, like all good armies, we don't deploy all of our weaponry in one go. We have an out-of-the-box configuration with a number of signals, many signals to start with. But we also keep some in reserve, but we can also develop new signals if we need to. Some are active, some are passive. So active ones are things that collect, what the user's doing, moving the mouse and so on. Passive modules are obviously interrogating the browser for information, confirming confirming what the user agent is, for instance, or collecting browser width and height and so on. So there's a mix of signals that we take. Next slide, please. Via this JavaScript. Now, our JavaScript is highly protected as well. So many of our competitors use kind of, more easily reversible, reverse engineered JavaScript, and it's, lightly obfuscated, let's say. So it's easily reverse engineered. Our JavaScript has our own unique obfuscation that we've developed, and we also revolve the obfuscation. So the JavaScript changes, it's dynamic. So even if, let's just say, even if an attacker could reverse engineer it, they have a window in which to use it, which is very small, a couple of minutes. But not only that, our JavaScript is different across our customers. So customer A's JavaScript is different to customer B's, is different to customer C. So if customer A's JavaScript got reverse engineered, it would be usable for a couple of minutes, but it would never be usable against another customer. But even then, it would be dynamically changed very quickly. So the window of opportunity is extremely small. So we've spent a lot of time and effort on that, and we feed into the JavaScript advisory board that controls new features going into JavaScript. Now, in terms of environment, we collect all sorts of data. So we collect information about plugins, installed fonts, screen resolution. We interrogate the browser to make it prove it is who it claims to be. So, for instance, how does it convert a number from hex to decimal? We know what the browser should do, so we can test them. And similarly, different browsers on different platforms will render images differently, emojis, for instance, and all this information feeds into our signals. There are many more. We can't go into details about all of them because that's obviously our secret sauce, as it were. All of those signals feed into the detection engine. Next. So part of these signals are used to generate an ID. Now, despite the fact there's a fingerprint image there, it is not a fingerprint. We mash these different data, or some of this data, into an ID which we can use to identify a specific browser server side. So obviously it's not ideal to identify traffic using just IP address. So we use something more sophisticated, but it shouldn't ever be called a fingerprint. Similarly, we can use headers to create patterns and also see, for instance, the order in which the headers are added. That's an indicator of certain tooling that's used. Next. And also we're doing behavior analysis. So we're looking at the activity, the cadence of typing, the way mouse events happen, so that we can capture automation. This is organic, so there's a certain pattern to it, timings and so on, and the way the mouse move is not in straight lines. Now, we use this data in and of itself, but we also create an ID from this information, and we attach it to a specific request as part of the telemetry. So each individual transaction also has an individual signature on, based on behavior analysis. Next. So you can see the difference between automation. There's no way a human can input 11 keystrokes in under 30 milliseconds. There's just no way it can happen. And straight line mouse movements are obviously indicative of automation. Next. Timings I've mentioned. So time to complete a form, or tab between fields and so on, is an indicator of automation. Next. And also we enrich the data pipeline. The data that we collect is also enriched with certain information. So, for instance, ASN information is added into the pipeline for analysis, and also geolocation information. So what do the signals look like? So client side, they're collected, they're then encoded and encrypted and attached to the outgoing request. Depending on how your application works, they'll either be added as a form, part of the form payload, or they'll be added as headers. For instance, if it's XHR, and you can see there's a few fields there. They are then sent to the shape engine via the load balancer, and then they're decoded and analyzed in a process we call inference in real time. That process takes on average less than 25 milliseconds in the shape cluster. So it's very quick, and a user will never know in terms of timing that is happening. Next. So on the mobile side, we can collect some extra information. There's an SDK that gets deployed, integrated into the app. So we can collect similar signals via a web view, but then, of course, being a device, you can access things like battery information, whether it's rooted, whether it's an emulator, and so on and so forth. So there's an extra layer of signals that come as part of the SDK integration as well. So we put all this data together, the browser signals, behavior signals, network signals, device signals, etc. That gets looked at in real time, and we come up with a decision about whether it's automation or not. Now, the key thing is about our platform, particularly SED, is that, and this feeds through into the other consumption models, which I'll talk about later, is that we're able to adapt these, the way we interrogate the signals, the way we come to our decisions. We can introduce custom signals if required. We can integrate, develop custom countermeasures. We can interrogate the signals in different ways. There's no kind of linear thing we have to do. We can do it it's very flexible in the way we can interrogate these signals. And that's a key part of our platform, is adaptability. This whole area is very dynamic in nature. As you guys will well know, anything to do with cybersecurity, you don't know what the attackers are going to do next, and your platform needs to be adaptable in order to be able to deal with that. And our platform is adaptable and flexible, so that we're not limited, for instance, to a kind of 3-month release cycle till we have a new feature. We can put our guys to work if we need to deal with a particularly pernicious and motivated attacker if required. Next. So just some examples here. If you just click Slobodan, please. So when we look at our data, we see patterns start to emerge. The guys doing this kind of automation, scripting of activity, go to great lengths to hide themselves. So you can see this guy here. In each click on the submit button, it's moving the mouse click down 3 pixels and across 1, down 3 pixels and across 1, and so on and so on. And when you look at this data, or you kind of zoom out and look at it as a whole, you can start to see these patterns emerge. Next. So this is a heat map of the difference between organic activity on the left and automated activity on the right. And overlaid, you can see that they're moving down to click on an accept button, but they're moving their mouse and their clicks around to try and hide themselves. But when you zoom out, you can see this, the difference between automation and not. The interesting thing, sorry, just go back. The interesting thing here is this particular website is a real customer website. They're quite a small local government organization, and yet attackers go to great lengths to scrape information from this particular site. Next. So just a brief view of the portal. In terms of Shape Enterprise Defense, you get full reports of in real time of the traffic that's flowing through Shape and being inspected. If you use other platforms like Silverline or the upcoming integrated bot defense, there'll be a slightly different reporting mechanism integrated with those particular platforms, but you'll still get access to identified and flagged automation that's attacking your site. Next. So in terms of architecture, next. So we have models which kind of fit almost any requirement, and depending on which Shape platform you decide, you can, some are available across all of them, and some dictate that you use a particular one. But we do have hosted solutions, cloud solutions, or on-premise. Next. And we also have different types of deployment options. So I've primarily discussed the fact that we would be in line, inspecting traffic in real time and also mitigating in real time. But we do also have an API option. So Shape is not in line. You basically utilize an API to send the signals to us. We send you a decision back, and then you can implement whatever mitigation you require. We have customers doing both of those things. Most of our customers go in line, but we do have people doing both. Next. So in terms of integrations, I'll just go over these quickly, the architectural diagrams. So we have cloud integrations which are available, and this covers SED, but if you use Silverline or integrated bot defense, then you'll have this kind of integration, but we'll come to that in a second. So you can the Shape real-time cluster can be hosted in the cloud and be integrated either via the CDN layer or from the load balancer layer. Next. We can be on premise, so we have physical appliances and virtual appliances which you can utilize, and you can host them. So typically banks use the on-premise option, as you might imagine, but many other customers go for cloud. And then we have the API integration, which can either be on-premise or in the cloud, depending on your requirement, where you are in full control of what you do with the telemetry and the mitigation. Next. So I know I've been talking for over half an hour, so this is the last slide, and then we can open it up for questions. So in terms of the ability to kind of consume the Shape product or the Shape service, because it falls under a managed service, there are different models. Now, I'll start on the far right, which is Shape Enterprise Defense, which is our kind of flagship product, which gives you like ultimate flexibility. You're able to, obviously you get the Shape bot detection engine. You can deploy, you can integrate either on-premise via a CDN, you can be inline, or you can use the API. In terms of the deployment into, for the Shape real-time detection cluster, you can deploy on-premise, in the cloud, or via our hosted, owned and operated data centers. The bot detection is fully customizable. You have a technical team which supports you, technical account manager and solution architects. They will customize the policy to your requirements, to your traffic requirements, to whatever mitigating action you require. And obviously everything's monitored 24/7. The mitigation policy is also completely customizable. You get full proactive monitoring, SOC monitoring, alerting, advanced reportings and threat briefings. So that's the kind of flagship product. And then you have different consumption models depending on what you want. So Silverline Shape Defense, we've integrated Shape with the Silverline Managed Service, WAF service from F5. So if you're running your traffic through Silverline right now, benefiting from managed WAF, you can turn on the automation protection in the UI. So it's all self-service. It's a cloud deployment, obviously, because you're using Silverline. It's deployed as part of the Silverline infrastructure. It is a generalized policy that gets updated on a regular basis, but your mitigation policy is configurable by you. So you can, if you want to send identified automation to a special page, or block the traffic, or respond with a specific custom response, you can do that. Obviously, reporting is all integrated with the Silverline platform, so it's part and parcel of your WAF reporting. and of course, you get access to the Silverline SOC. There's a new intermediate offering, which is we're calling integrated bot defense, which allows an on-premise or CDN integration. So we provide, for instance, we provide an IAP that you can use to configure big IP to enable this. It utilizes the API. The signals get sent to the Shape cloud infrastructure. We send a decision back, and then you mitigate within an eye rule. Again, this is a global policy. So there are multiple different ways you can consume the advanced Shape bot detection capabilities, and then mitigate to your requirements depending on your need. Bigger customers that have more sophisticated attacks usually go for Shape Enterprise Defence, and then the other, there are other mechanisms to make the Shape technology available in different formats. I'll stop there and open it up for questions. I hope that was a good overview.
For me too, a good overview. Thank you for that.
No problem.
If there are no questions, and I don't see questions coming in, let me tell you that I'm going to send out information on a Shape Defence ID as well, and a way to make a lot of money for the resellers.
Yeah,
we'll absolutely follow up on the partners. Thank you for being here. Slobodan, thank you very much for helping us with the technical problems. And of course,
I'm now called. Sorry, I talked over you, but I'm now called Next Slide Slobodan. So that's my official name. Of course, it was a pleasure, and I would really also tell you to watch out for integrated bot defense, because I think it's also going to be a great opportunity for partners, because you can deploy it as part of the big AP architecture very easily. So we'll be open, Jamie and I, to kind of assist and help with any sort of requests and to get you able to serve the customers.
Yeah, I mean, yeah, if you, I can say a few words about device ID if that would be useful.
Yeah, sure.
Yeah, I mean, device ID is a free service that F5 make available. It's based around Shape technology, which we took out. I mean, we added it into Shape Enterprise Defence, and we've taken it out and made it available as a separate service. And essentially, it gives you the ability to, it utilizes some of the Shape signals to generate a device ID that then gets a customer can use to plug in as a data point to do device profiling, user profiling within their own analytics databases. So we generate a device ID, attach it to requests going to the origin. At the origin side, that device ID can be consumed and extracted and put into some kind of engine which is profiling user activity. It can be used for security purposes. So if you're building your own risk-based authentication engine, device ID becomes an important constituent part of that, and you can utilize ours for nothing. Also, if you're building some kind of marketing analytics database, device ID can be used to join that activity together and look at that activity, and you can use it for marketing activities, maybe presenting a real-time offer to someone that you're confident is coming from the same device and has come multiple times, for instance. So there are multiple uses for it, and it's free. So you can use it as a building block of some kind of user analysis and profiling capabilities.
I just put up the slide that shows some of the ratios we can provide that can be used for risk management, for traffic management, or as Jamie said, marketing. So we basically give you more visibility into the traffic and try to uniquely identify devices accessing the applications. And there can be multiple uses as enriching security information, and managing risk control, or simply boosting the user experience and removing friction. So quite exciting technology and multiple different uses that also require help with integration and application development as well. So I think it's going to be an interesting offering for the channel.
Yeah, absolutely. I'll share that information with the partners. If there aren't any questions, I'd say enjoy your lunch. It will take another hour for you in the UK, of course, but we are here to 12 over here.
Okay.
Do enjoy the sun as well, because the weather is lovely at the moment.
Exactly.
Thank you all for being here. I'll be in touch. I'm sales, so I'm supposed to.
Okay.
Good afternoon.
Thanks, guys.
And I hope to see you soon all again.
Thank you. Bye-bye.